Good afternoon, everyone. My name is Sarah Duffy and welcome to today's masterclass. ASTN continues its masterclass series, The Impact of Technology on the Business of Sport, with today's webinar on artificial intelligence in sport. We have guest speakers joining us today that will also form a panel discussion with the chance for questions just before we wrap up around 3 p.m. I'd first like to begin by acknowledging the traditional owners of the land on which we meet today. I would also like to pay my respects to elders past and present, and also acknowledge the support that we've had from the Western Australian Government, Department of Jobs, Tourism, Science and Innovation, Queensland Government, Department of Tourism, Innovation and Sport, and the Victorian Government, the Department of Jobs, Skills, Industry and Regions. Our first speaker I'd like to introduce from the ASTN, our chair, Martin Sleigel. Martin is the Executive Chair of ASTN. His work focuses on ASTN's knowledge programs, startup mentoring, and global partnerships with other clusters of innovation. Previously, Martin worked in various executive positions in the USA and Australasia, including management roles in business information technology, quality and process, engineering and business, M&A. Please welcome Martin.
Yes, Sarah, thank you very much, and good afternoon, everyone, and welcome to this webinar. I'd like to start with just providing a little bit of background on the ASTN. And for those who don't know what the Australian Sports Technology Network does, we're an industry-led membership organization that provides knowledge to engage and connect industry. We operate Innovation Hub here in Melbourne, Australia, and we foster connections between industry, startups, users of sports technology, rights holders, and many stakeholders in the industry. We operate what's called the Australian Sports Innovation Centre of Excellence, which effectively groups all of the program activities that the ASTN runs under one umbrella. And we're rolling these activities also out into our state nodes across Queensland and Western Australia, as Sarah mentioned. As a membership organization, I'd like to also take the opportunity and thank our premium members who are supporting us not only by participating and contributing to our programs, but also by supporting us with other contributions to the activities. Let me begin with giving you a little bit of background why we wanted to bring this webinar to you. And for those of you who are familiar with us, the ASTN has now published its second sports innovation report. And in that report, we continued to identify and define what we call sports tech now. And I'd like to put an emphasis on what we call the technology stack, and in particular, the information and communication technologies that our companies are using to build their products and services. And as you can see, one of the cornerstones in that ICT column is artificial intelligence. And I'm not telling you any secrets, but across different industries, we're hearing about what artificial intelligence, or short AI, can do or change. And therefore, we wanted to bring this webinar to you today. We've also identified that obviously artificial intelligence in sport has some importance in terms of its potential use in analyzing historical data, making predictions, but also influencing questions that we probably cannot answer at the moment because we can't process the sheer volume of data, or we do not find the underlying connections that certainly machine learning algorithms could identify. And it's not only important for the user, the person that wants to rely on the outcome of that technology or that technology produces, but it's also important for our companies in the ASTN network, because as I said, a number of more than half actually of companies in our network actually rely on ICT technologies to build their products. So with that, I'm really looking forward to the seminar this afternoon, and thank you all for joining in this afternoon, and hand back to Sarah. Thank you.
Thank you so much. Coming up, we have three different panelists for you. We have John, Rita, and Stuart. But first of all, I'd like to introduce to you John. John is Director of CSIRO's Data 61, the digital and data science arm of Australia's National Science Agency. With around 1,000 staff and affiliates, Data 61 is one of the largest collections of R&D expertise in artificial intelligence and data science in the world. Prior to joining Data 61, John was Dean of the Faculty of Information Technology at Monash University and a former technical area lead at NASA, where he worked on software for NASA space missions. Please welcome John.
Thanks, Sarah. I'm just sharing my screen. All right, welcome everybody. Great to be here. My job in the next 15 minutes is to take you from zero to hero on all things artificial intelligence. So no small task. And I wanted to start just by talking about where we are now in 2023. So I'm sure that if you've picked up a newspaper or listened to the radio or been on social media, you will have seen a lot in your feed about artificial intelligence in the last 6 months. And I've been calling 2023 the year of AI. And that is because although AI has been around for quite a while, we've really seen an upsurge in media interest, in industry interest from any industry, really since ChatGPT, this large language model AI system that allows you to converse with it in much the same way that a human would do, was released onto the world in November of last year. And at the time, that was the most quickly and widely adopted technology that has ever been invented, you know, more quickly adopted than the internet, more quickly adopted than the mobile phone. And I'm sure you've all played with it. Normally, if we were face to face, I would ask my audience at this point, how many people have heard of ChatGPT? 95% would say they had. I would then say how many people have used and played with ChatGPT. I'd say probably it's usually around 85% that say they have. But I then ask how many people are actually using ChatGPT on a day-to-day basis as part of their work. And that's a much smaller number right now, probably 5 to 10%. So I think it's still an emerging technology. And in fact, ChatGPT is really only one kind of AI. It's what we call generative AI, which is AI that will generate content for you, whether that's text, whether it's images, whether it's video, or whether it's music. But there's lots of different types of AI that have already been used in various industries for decades. Machine learning, automated decision-making tools, computer vision that can recognize objects in images or in video feed, and all different kinds of AI. But it's certainly true that since ChatGPT came onto the scene, we've seen a massive rush, almost an arms race, you could call it, in terms of getting new AI products out to market. And I always use the date of March 14th, 2023, just to illustrate how quickly things are moving, because on March 14th, 2023, there were two major global press releases that on any other day, in any other world, each would have grabbed the headlines, but only one of them grabbed the headlines. The first of those was on the morning of March 14th, Google announced that it was going to incorporate its AI technologies, such as Bard, into the Google Workspace tools. So it would become a standard part of Gmail and so forth. Now, that's a big deal. That's a really, really big deal. But it received almost no media attention because a couple of hours later, OpenAI, the company behind ChatGPT, announced that it was launching its biggest model yet, GPT-4, which the community had really been waiting for in anticipation. with more than 1 trillion parameters in its model, and that stole all the headlines. So that's how fast things are moving, that, you know, on that single day and within the space of a couple of hours, 2 major announcements, and only one of them really got any airtime. And we've seen hundreds and hundreds of AI products launched in the last 6 months, and they're disrupting just about every industry you can think of, including sport. I do just want to step back a little bit, though, because AI is actually not a new technology. In fact, AI has really been around at least since the 1950s. The term artificial intelligence was coined at a conference of computer scientists in 1956 called the Dartmouth Conference. And, you know, in the 1950s and the 1960s, a lot of the basic algorithms that we use today in AI were invented. They weren't applied at the same scale or with the amount of data that we have today. But a lot of the core ideas behind AI have really been around for around 70 years. And I think it's always worth bearing that in mind. It's also worth bearing in mind that in those 70 years, we've gone through various kind of hype curves with AI, and then various kind of eras of disappointment when it comes to AI. And we call these AI winters and AI summers. So AI summers were when lots of excitement around AI, lots of investment going into AI, a bit like we are now, but typically followed by an AI winter where it was realized that some of the promises that people were making about what AI could do were not going to happen as quickly as we thought, and investment dried up. So the first of those AI winters happened in the late 1970s. Back then, it was seen that AI was, you know, the killer app for AI was machine translation, translating between different languages, which of course we have now. But back then in the late 70s, there was a famous report called the Lighthill report that came out from the UK government that showed that a lot of the hype around machine translation and AI at the time wasn't materializing. And almost overnight, investment fell off a cliff. AI did recover, however, and it had another surge in the 1980s. But towards the end of the 1980s, there was a second AI winter. The killer app back then was what we call AI expert systems, or AIs that can actually make decisions that humans normally would make. And there was particular interest in applying those in a medical context and having AI that could essentially replace or work alongside your doctor and diagnose diseases. But towards the 1980s, quite rightly, there were questions raised around the ethics of that and issues of the AI making false diagnoses. And again, we went into an AI winter and things kind of fell off a cliff. We're in a third AI summit right now that's probably been going on since around 2012, when something called deep learning was invented, which is really an algorithm that allows some of those AI algorithms that we'd had since the 1970s to scale up. And it's got particularly, feverish since 2017, and then again since ChatGPT last year, when the core technologies behind what we call large language models were invented. And this is the idea that you don't have to create a kind of bespoke model for a bespoke data set in particular industry, but you can actually have these quite general purpose models like ChatGPT that can converse with you on a whole range of different topics. Now, we are in an AI summit, and there are lots and lots of opportunities for AI. AI is disrupting just about every industry that you can imagine. Sport is no different. You can look at AI in healthcare, where AI is being used to reduce the time that it takes to get results from breast scans. You can look in AI in space, where there are rovers on Mars that are actually doing interesting science fully autonomously. AI in manufacturing, where there are AI systems on the production line that can automatically flag defects in produced artifacts. AI just about everywhere you can imagine, and it's really being quite a disruptive force. Although fair to say, I think that a lot of industries are still trying to figure out exactly how to use it. I won't go too much into sport because some of my colleagues are much more well-versed in this subject than I am, but I just wanted to point you to my own podcast. I have a podcast called Everyday AI, which you can think of as a gentle introduction to AI. It's AI for a general audience. I've had 6-year-olds listen to it. I've had 86-year-olds listen to it. And one of those episodes specifically deals with sport. In fact, one of my fellow panelists today, Stuart Morgan, is featured on that podcast and does an outstanding job. And if you look at some of the examples where AI is revolutionizing sport in that podcast, it's some of the more obvious ones that you might think of. So optimizing athlete performance. And there's a nice example in there of hockey, the Australian hockey team, and how they use that to experiment with different interchange rates of taking players on and off the field, and then using a kind of data-driven AI approach to kind of evaluate whether that strategy was really working or not. But it's not just in performance. AI is also being used in helping to prevent injuries in athletes. In fact, we've got some work going on at the CSIRO, which is a kind of AI camera-based system where you can point cameras at athletes while they are carrying out their sport. And it's got the laws of, it's got biomechanics built into it. So it can actually annotate that camera feed with the stress on joints at any given point in time. And it can flag if there's a potential injury that's going to come up because there's too much stress on the joints. I happen to be a fairly serious amateur weightlifter, and that kind of application to me would be amazing because it could give me real-time feedback on how good my technique is and whether I'm doing something that I shouldn't be doing that might lead to an injury. But AI is also being used in making sport more entertaining for spectators as well. There are examples in basketball, for example, where there are AI systems that will calculate how difficult a shot is before the player takes it and then present that information to the viewers. And that creates a more interesting experience for those watching sport. And it's even being used to make sport more inclusive. There's a nice Tennis Australia app that's also featured on that podcast episode that is helping blind spectators at tennis matches actually watch tennis in real time by giving them headphones and using AI to automatically annotate the tennis match with sound effects so that they can actually follow along the tennis match using sound instead of having to take a friend along who would kind of commentate for them. And of course, more broadly in the sports industry, whether it's logistics or just ticketing or all kinds of different parts of the sports industry, we're seeing AI applications come to the fore as well. I do want to talk about some of the risks associated with AI as well, because like any new technology, AI brings lots of opportunities, but there's lots of risks that we ought to be aware of, and that's as true in sport as it is in other industries. And in fact, as early as 2019, we at the CSIRO worked with the federal government to come up with a set of 8 high-level ethical principles that anybody thinking about developing or adopting AI should try and adhere to. And these are designed to try and make sure that AI systems actually maximize the benefits that come with AI, but minimize any negative consequences that might come. And in terms of what negative consequences could come, well, if you look at tools like ChatGPT, it's well known that they have the tendency to hallucinate facts. They make facts up. And that's really because all that ChatGPT does is to identify patterns in huge amounts of textual data that was collected from the internet, but it doesn't have any understanding of that textual data, and so it's doing kind of fancy word prediction, if you like, which means that it can easily put words together that might be grammatically correct but are factually incorrect. But there's also examples of AI systems that are generating images, for example, that are biased and racially discriminatory. An early example of that was an AI system that was used in law courts in the US, where they were using it to try and predict the reoffender rates of criminals coming up against parole boards. And unfortunately, it was shown after the fact that that was biased against Black people. In a sport context, that I think there's more and more data being collected and used to optimize sport about athletes. And there are ethical questions around who owns that data. What happens if the athlete moves to a different team? Does that data go with them? Is it ethical to be, collecting data from athletes essentially kind of 24/7? I won't provide answers to those because I'm sure my sports colleague are better well versed in that. But it gives you an idea that even in areas where you think there might not be any ethical issues to deal with, there are. And that's why these ethical principles exist, because they lay out kind of 8 high-level things to be aware of, like trying to make sure that your AI systems are fair and inclusive, that they can explain why they've made such decisions, they're transparent about what they do, and that people using them actually they know they're using them, and they have a right to appeal any decisions that they might make. I do believe, however, that we can get the best of both worlds with this, and we've certainly done a lot of work at CSIRO trying to come up with guidance and frameworks to allow industries and companies to get the best of both worlds. It's not a technological issue as such, actually. It's a socio-technological or organizational technological issue. So these kinds of AI risks really need to be considered at a governance level. So if you're using AI within your company, you need to be thinking about what governance frameworks you have in mind to make sure that that's done ethically. You need to be thinking about it from a process point of view. So what processes do you have in your organization where you're adopting or using AI? And how can you be sure that those processes are going to flag any potential ethical issues and deal with those ethical issues? And you also need to be looking at it from a kind of product point of view. Most AI procurements actually don't procure one AI system. They procure multiple AI systems and they chain them together. And so you've got to consider the weakest link in the chain from an ethical point of view, and be sure that if you've got a supply chain with multiple AI systems in the mix, that all of them are being considered from an ethical point of view. I will just finish. I'm always asked when I give talks about AI, no matter what industry I'm in, how should we start? And in particular, if we're an organization that wants to come up with an AI strategy, what should we do? And my standard answer to that at a very high level is to think about 3 questions. So the first question is to really focus on the problem that you're trying to solve. AI may not be the solution. And I do find this a lot in industry, that people are wanting to jump on the bandwagon of generative AI in particular and apply AI. But it serves you well to just kind of step back and think, well, actually, what problem am I trying to solve first? There might be a much simpler or much easier solution. Secondly, once you've figured out what problem you're trying to solve, you then have to ask yourself, well, is AI the right solution? And one of the things about AI, because it's driven by data and large-scale statistics, it's unlikely to provide you with 100% accurate answers all the time. Now, that's maybe perfectly fine in some scenarios, but not in others. So if you're just using AI to recommend movies to watch, it's perfectly fine. If it gets it wrong from time to time, no one's going to die. But if you're coming up with self-driving cars, then you need very, very high levels of accuracy. And so that might give you pause about whether AI is actually the right solution or not. And then the third question that I recommend people ask is, do you have the expertise to implement these AI solutions? AI solutions are great, but they're not off the shelf. And you typically need to put quite a bit of effort into making sure that you've got the right data to train the systems on, that that data is treated in a particular way. And also that you've got at least some in-house expertise who knows something about AI and machine learning, so you can actually apply that in your particular context, and you can actually modify that as you go. So those are 3 questions I would recommend. And the last thing I will say is that we've got the Olympics coming up in 9 years, almost 9 years to the day. And one of the things I've been saying to anybody who will listen is, wouldn't it be great if we had a version of the Olympics running alongside that was the AI Olympics? So let's use that as a North Star, as an opportunity to showcase Australian AI on the world stage in the same way that we're going to be showcasing Australian sport on the world stage. And that might finally do something to boost our tech sector internationally, which many of us have been hoping and longing for a long time. And I'll stop there. Thank you very much.
Thank you so much, John. So we've got 3 guest speakers for you today, which will all be part of a panel a little bit later on. So we've just finished up with John. If you've got any questions, I'm sure from everything that John was talking about, there'll be things that you would love to ask. So write those down and we'll have the opportunity of a chat a little bit later on. And some of those questions, if we get time, will be able to come up and be asked to our panelists. Coming up now, Stuart is the Director of Machine Learning at the Australian Institute of Sport in Canberra. He worked as a sports analyst at the Victorian Institute of Sport before commencing as a senior analyst leading the data analytics unit at the AIS, developing next-generation game analysis techniques. His current work is in the development of artificial intelligence algorithms for computer vision and large-scale data analytics in sport. Please welcome Stuart.
Thank you very much, Sarah. I'm just going to attempt to share my screen. I think I should have that. Right. Well, thank you very much for the opportunity to present. And I think my job after that great presentation from John is to dive into the weeds a little bit in terms of high performance sport and the ways in which artificial intelligence has been of utility for us, and in particular to end coming back out of the weeds a little bit and start looking over the horizon at some of the ways in which we think there is competitive opportunity and competitive advantage to be had as we look towards the 2032 Olympics, which is the big North Star for us, less than 10 years away. I like to start some of these presentations with this slide. I mean, sport is stratified by often the smallest of margins. And in a 100-meter sprinting race, it can be fractions of a second that separate the gold medalist from the also-rans. And in every instance, if you look at the competitors in 100-meter sprint at the Olympic Games, every one of them is genetically gifted, and every one of them is incredibly well trained, and every one of them has what we call in sport the fundamentals right. So they've got great sports scientists, great coaches, great sports doctors, physiotherapists, great training facilities. And so in every instance, all of the ingredients of an exceedingly good performance are there ready to be executed. So the question is then, how is the field stratified? And it turns out to be really small margins. So I like to think about this as an analogy also for the space that we compete in terms of technology. All of the countries that turn up to the Olympic Games, and I should precede all of my comments that at the Australian Institute of Sport, we're primarily focused on Olympic Games sports, Commonwealth Games, but our big ticket items, particularly as we look towards the Paris Olympics, are our Olympic and Paralympic sports. So in every one of these sports, we're looking for small advantages that can give our athletes and give our coaches small insights that are just able to nudge that dial, even by the smallest of margins. Because in many sports, as we say, the smallest of margins can be the difference between a gold medal or missing out altogether. So what I'd like to do today is talk about the ways in which we're trying to nudge the needle and some of the things we've done historically in that pursuit. And again, John alluded to this, some of the work that we've done right from the very beginning in player tracking was designed to support a coach's intuition about whether or not playing a particular kind of strategy could manipulate one's opponents. And key to that was being able to measure opponent behavior. And when we began this work in around about 2010, there was no pre-existing way, certainly no ad hoc or low-cost way for us to measure the behavior of opposition teams. So that was really the project, the catalyst for our journey in computer vision. And I should point out also that this work preceded a lot of the deep learning and what we now call AI driven solutions to computer vision. It was a much different proposition in those days. But being able to track players is an important component of many of our sports analytics pipelines. One potential use case for tracking data is to be able to autonomously select a broadcast view. So using a high quality background feed coupled with player tracking detections, we're able to customize a multicasted viewpoint And in this way, we can have a range of different viewpoints, and we can also automate the process to prevent to alleviate some of the human resource concerns that we have. Another example of some of the kinds of work we're doing is, again, in the computer vision space, is to try to track and understand something about performance in training. In many cases, we're trying to understand something about behavior during the training environment, and provide a platform or an environment where the coach and the athlete and an analyst, coupled with data, can explore and improve behavior. And in this instance, what we're trying to do, and this solves a problem for track cycling on the velodrome, riders in the modern day events use really big gears, which require a lot of strength to overcome inertia and get the bike moving. So one of the ways that the riders solve this problem is to throw their body weight over the bottom bracket, which is the axle, the pedal axle on the bike. The more quickly they can do that, the more they're able to break the inertia of the bike and get the bike rolling. So a key parameter for coaches is to be able to measure how quickly is the hip moving across the bottom bracket. It's a key metric, and it's a real skill in of itself. Previously, we had a PhD qualified biomechanist manually annotating this kind of information, and it would take about 40 minutes per track start. So therefore, the time from the execution of the task through to the point where a coach, an athlete, and an analyst can work through the metrics is somewhat delayed. So we built this system as a way of automating the process such that by the time the rider finishes a lap of the velodrome, comes back to the starting point, that information is available, and they can evaluate, to potentially make some technique changes, and then re-execute the skill. Another piece of work, a substantial piece of work that we engaged with Swimming Australia and the Trade University, was to build a system we call Sparta 2. And the underlying premise here is that coaches like to be able to understand a whole range of performance metrics for their swimmers in a race. How far are they traveling with each swimming stroke? So their stroke length, their stroke rate, so how frequently, how many strokes per minute are they able to execute? What's their instantaneous velocity? How fast are they traveling at different parts of a lap? What are the turn times? How quickly can they execute a tumble turn and then resurface on the subsequent lap? And in fact, there's a whole range of metrics that coaches are particularly interested in. The historic approach to doing this has been, again, for PhD qualified biomechanists and sports scientists, to manually annotate when a hand enters the water. And again, it's laborious, it's prone to error, it's usually done well after the competition's finished. And so the time from performance to feedback is again extended, and so coaching opportunities are lost, and those coaching moments that we talk about, an opportunity for a coach, an athlete, and data, that kind of symbiotic relationship to exist, that's delayed or lost altogether. So our objective here with this system we call Sparta 2 was to be able to automate this and to do it really quickly. So now it's possible for the results, for the analytics to be available very quickly after an event, and critically for that information to be available to the coach between events. So if a swimmer swims a heat and then a semi and a final, there's an opportunity to review performance in between those events. And the final piece of this puzzle, I think, which is really important, is that because we can automate this process, and it happens very, very quickly in relative terms to human annotation, but we can also do all of the swimmers in parallel. Previously, there was a barrier to that because we would manually annotate each swimmer in series. Doing them all together in parallel and automated means that we now have an efficient way of gathering data about the whole of race dynamics. What are all of the swimmers doing, and how does the race evolve? What are the pacing tactics, and what are the dynamics of a race? So it's more than just automating a previously manual system. It's now providing new information and new insights that coaches haven't had in the past. We're very proud of the system. It's taken a lot of work to develop, and we are, at least at the Tokyo Olympics, the last Olympics, we were the only people there with it. And so we're expecting to see other analogues of this system appear in Paris. Again, as we get more and more sophisticated with this work, as AI enables the work that we're doing in computer vision, it's possible now to do multi-camera evaluations of human pose. This is a system that's installed at the Western Australian Institute of Sport. It's a multi-camera system, and we're able to, without markers on an athlete, track them as they pass through a pass over a bar. This is an interesting problem for pole vault coaches. Often an athlete will reach the required height, but they might hit the bar on the way up, or they might reach the height and then come down on top of the bar and dislodge it. And so there's a whole range of free parameters in how you approach the vault, where the standards are set, the uprights that hold up the bar, which is one of the free parameters for the athlete. And again, this is a system that allows us to non-invasively measure behavior and allows us to provide feedback in an autonomous way, in a timely way, so that we're trying to enable these interactions again between coaches, athletes, and data. I love this image. This is my final example of the computer vision work that we've been doing. This is, in white here is Kelsey Lee Barber, a two-time javelin world champion, and her coach, Mike, with their biomechanist and a sports scientist. And they're standing trackside following a bunch of throws and evaluating the metrics from those throws. So this kind of trackside reevaluation of performance enabled by data is a really important exchange, and it's something that is central to the work that we do. And this is enabled by an app. My colleague at the Institute of Sport, Ash Hall, developed this from the ground up. It runs trackside and it autonomously recognises when somebody throws a javelin, tracks the body parts and relevant features, the javelin, measures autonomously a range of important metrics that the coach is specifically interested in. And it happens really quickly. Again, it happens in a matter of moments, so that once the thrower has executed a bunch of throws, they can collect alongside the iPad and review that kind of performance. So for a long time, these have been the kinds of insights that we've been able to derive, and we've sought competitive advantage by enabling faster and more autonomous and ideally more reliable metrics to be gained from training and from competition. One of the virtues of artificial intelligence is that, again, as I think John mentioned earlier, is that models, when they're trained on sufficiently diverse training sets, can be very generalizable. We've built a lot of our own models because sport is a distribution all of its own. But if we train those models on sufficiently broad data sets, then a 3D pose model that works well in pole vault will work equally well in javelin or in a basketball throw or in a tennis serve. And so we're able to take these sport-specific implementations and generalize them and place them on a platform that we call pipelines that runs in the cloud. And the idea of pipelines is to enable our national high-performance network to access the core components of our computer vision and AI capability and assemble their own pipelines, assemble their own pathways from video as input through to some kind of meaningful output that is relevant and important to them. We're an incredibly small team, so we don't have the resources to build a system from the ground up for every sport. So the value proposition for us in assembling this platform is that we can provide the backbone for individualized video analysis systems, and without code and without requisite hardware and without really any, beyond the conceptual understanding, any computer science expertise, we can enable people across the network to build their own pipelines and to assemble their own video analysis systems without us having to customize those and support them and build them. So that's an important feature of our work as well. We are currently around about a year away from the Paris Olympics and 9 years away from the 2032 Olympics. And while we think that we are early adopters in some areas of computer vision, and certainly as I mentioned, Sparta 2, our swimming system is the first of its kind to be deployed, we expect that early adopters advantage to diminish relatively quickly over coming years. Computer vision driven by AI is exceedingly accessible now, and with a very small amount of coding, it's possible to spin up systems with a level of sophistication that would have been really state-of-the-art even just 5 years ago. So the accessibility of computer vision and the speed with which it's possible to build up new systems means that we have competitors nipping at our heels probably very quickly. So we start asking ourselves now, what are the next competitive advantages for us? And when we think about artificial intelligence and even more broadly technology in sport, I think it's important to think about what actually makes it a competitive advantage. And for us, I think several features are important. It needs to be unique. We would like to be the only people in the world who have the new technology widget that accumulates gold medals en masse. We expect, as I said, that computer vision is becoming more and more accessible and is drifting into the business as usual domain for many sports applications. So that's no longer unique. And we need to start looking elsewhere for new advantages. It also needs to be actionable in the sense that we can use the insight to manipulate the outcome of an event. One of the things I particularly like about our Sparta 2 system is that the timeliness of feedback enables the coaches to evaluate features of a performance, interact with the athlete, and then make subtle changes for subsequent performances within the time frame of a multi-event format. So that makes it actionable. The example that we used earlier about field hockey coaches using insight from player tracking data to understand whether or not they've been able to manipulate their opponent in the ways that they expected to is another example of ways in which intelligence can be actionable. So we're looking for ways that we can deliberately and systematically manipulate our opponents. And finally, it should be difficult to replicate. It shouldn't be something that people can quickly follow. If we deploy a system at Olympic Games, we would really not like to see the same system deployed 12 months later. So I think there are opportunities in artificial intelligence that require, at this point, a lot of expertise and a lot of experience and a lot of capability. And I think those are areas at the moment that are proving or are likely to prove more difficult to replicate. So we started to play in the area of reinforcement learning in team sports. We did some early exploratory work with La Trobe University and University of Adelaide in soccer, and we were particularly encouraged to discover that intelligent multi-agent AIs could learn some fundamental principles of soccer without being prompted. For instance, the defensive unit learned to set an offside trap, and we saw a bunch of other insights that gave us encouragement that that reinforcement learning agents could solve or address complex problems in sport. And we're certainly seeing this outside of sport. We're certainly seeing in a number of different domains that reinforcement learning algorithms and other generative AI are able to not only solve complex problems or optimize complex spaces, but in some cases discover new approaches to problems that were previously thought of as where the thinking perhaps has been previously thought of as being solved or exhausted. Might be worth stepping into just a brief description of what we mean by reinforcement learning. If people are unfamiliar with the idea, generally speaking, we're trying to train an AI agent to learn how to interact in an environment and to solve problems within that environment. So typically an AI agent will choose some mode of action, and then there will be a reward or a penalty that relates to how successful that particular action might be within the environment. And then over hundreds of thousands or more iterations, the AI agent learns quite sophisticated, in many cases, approaches to solving problems within that environment. So if we operationalize that idea and we think as a thought experiment about track cycling, the 4,000 meter pursuit program, the discipline here involves 4 riders from a standing start riding together as a team and riding as quickly as they riding as quickly as they can to complete 4,000 meters. It's a non-interactive sport, so there's no interaction with other teams, but there are loads of free parameters here. The riders, typically the rider in front will be doing a greater workload than those riders who are trailing because of the aerodynamic and saving effects. So there are strategies around how do the riders rotate? How long should a rider be on the front of the group for before they slide to the back and take a relative rest? Which riders should you select? What are the physiological properties that are relevant to the domain and other new ideas we could think about? And then a whole range of equipment and interactive equipment choices. What's the right equipment for the right riders, and what are the right gear ratios? What are the right pacing strategies? So it's a really complex environment. It's a really complex problem to solve that requires thinking about a very high number of dimensions. So we like this kind of problem as one of the potential use cases for generative artificial intelligence. So if we think about the same idea, we have an AI agent that's trying to solve a complex problem. The environment is the execution of a 4,000 meter pursuit, and we have a range of testable ideas, and the reward is simply a simulated race time. So we're looking at ways in which we might be able to deploy reinforcement learning as a means to solving these kinds of problems. Now, in my final slide, I want to mention the work that we're now doing with Data 61. We've commenced this work only in the last month, and we're doing this in collaboration with Tennis Australia. Our objective here is to explore whether or not we can train a generative AI agent, a reinforcement learning agent, to take the role of a tennis player and try to solve strategic problems in the domain of tennis. And we like the idea of kind of testing scenarios in this sense. So if our reinforcement learning agent was playing the role of Nick Kyrgios, and Nick Kyrgios is playing against Novak Djokovic, we would like to be able to advise Nick Kyrgios about some of the ways in which he might be able to manipulate the gameplay and control his game in such a way as to optimize his chances of playing well against Djokovic. We might hope that the AI will suggest that there's particular combinations of shots that lean towards Nick Kyrgios' strengths and lean towards Novak Djokovic's weaknesses. And these are things where maybe a coach has some kind of intuition, but we'd like to be able to test those intuitions as well. We'd like to be able to test it in silico and perhaps explore whether or not in a simulated sense at least, what we think might happen under certain conditions will actually happen. For instance, what would happen if Nick Kyrgios was injured, and what if he lost some of his mobility? What are the ways in which over hundreds of thousands of iterations of trials where the agents are constrained by the relative strengths and weaknesses of each of the players involved, whether or not there are ways that Nick Kyrgios could mitigate against the risk of being exposed to that injury? Are there particular shots that he could select, for instance, that might limit his exposure to Djokovic's strengths and limit his exposure to his own movement incapacity? So I think there are lots of opportunities for us in this space, and we're looking forward to some of the work that's literally just rolling off the presses as we speak. So finally, I just want to finish on, as we look towards 2032, where is this going to take us, and what are the things that we're hoping to achieve? I think we have a little bit of an internal timeline here. We look towards 2028 as being the point at which we want to be AI ready. The rate of change in artificial intelligence is so great that it's probably perilous for us to invest too heavily in or bet too heavily on a particular mode of artificial intelligence or a particular thread as we look towards 2032. So what we want to do at this point is build our capability and build our understanding of the domain and build the breadth of our AI toolkit, so that by the time we reach visibility of the 2032 Olympics, we're in a position then to start to sharpen the edges of our tools and focus specifically on on where we think the big opportunities are going to be and the big gains to be made in competition. And finally, I think it's always worth making the point that we, in all cases here, and I hope it's a message I've conveyed in my talk, that we're trying to augment the skill sets the coaches have. We're trying to provide coaches with insight. We're trying to provide them with metrics and understanding of the features of performance in training and competition. So in every instance, what we're trying to do is augment the capability of our coaches with insight that's, as I said, is unique and actionable and difficult to follow. So thank you very much.
Thank you so much, Stuart. We did have a question come up during your presentation from Taylor. We will save that question until later for when the panel discussion happens. So Taylor, know that your question will be asked a little bit later on. Next up, we have Rita. Rita is Strategic Engagement Manager at CSIRO National AI Centre, focused on building a responsible AI network, a world-first cross-ecosystem collaboration aimed at establishing and sharing the best practice of responsible AI in the commercial sector. Previously Deputy Director, Centre of Industrial AI Research and Innovation, Chief Digital Advisor at Microsoft, she cultivates innovation with emerging technologies, including artificial intelligence, machine learning, mixed reality, and digital twins. Please welcome Rita.
Thank you so much, Sarah, for that wonderful introduction. And I only have a bit of information I'm going to be sharing with you today. And Stuart, you're a hard act to follow. So here we go. Green, this one. Sorry about this. Just give me one more second. Okay. I should be sharing now, correct? So as you know, my name's Rita Rigo. I'm just going to spend a bit of time telling you a little bit about the National AI Centre and some of our initiatives in this space. So the National AI Centre was established to help accelerate positive AI adoption of innovation that benefits business communities across Australia. And we're doing that in 3 ways, from helping communities get started with AI through to sharing details about some of the AI partners that we have in Australia and some of the AI solutions that we're developing, through to uplifting practice with the Responsible AI Network that Sarah talked about. So the Responsible AI Network is a super important initiative. It allows us to provide a whole lot of detail and support to the community of people who are developing AI to help make it more responsible. And we're doing that through law, through standards, through design, leadership, principles, technology, and governance. And you can find out about some of the initiatives in this space by visiting the National AI Centre website, where we are having webinars and white papers and different community initiatives around helping to support this idea of responsible AI, which we hold very important at the moment. In addition, some of the work that we've been doing is working closely with, of course, CSIRO Data 61. And it was really amazing to see Stuart's reference to some of the work that the Australian Sports Institute have been delivering around taking that combination of understanding the physical body and to be able to get a biomedical model of that, and then be able to conduct, real-time assessment of what's going on with the physical body. And it's really interesting because sport is the ultimate innovator. So we did actually start in this space looking at elite swimming and dive mechanics, and now it's been pivoted to really look at the way that we can take this digital human body understanding into factories, into the office, and be able to more deeply understand what's going on with identifying movements of high risk on the body. So it's amazing how sport is always such an innovator. This is some of the work that we've done previously with dive mechanics, etc. So the other area that I find really interesting is this opening up of skills that are available to the rest of the community. And the AFL Skills Lab developed by Google is an excellent example of this. So it uses your smartphone camera and Google AI to recognize and track your footy skills, so it can understand within the frame, and the AI models can give you actual advice. For example, I've never done figure eights before, and last night I was like doing figure eights and it was telling me, you know, how to do them. And it's just amazing to see these kind of AI now being made available to people in the community as well, so that they can also use AI to improve their skills. This is actually downloadable if anybody wants to use it by just typing in Footy Skills Lab into Google, and you can find it and install it on your phone or use it on your PC. Another really interesting initiative that that I can share a little bit about is Adam Goody's AFL Data with Aboriginal Knowledge. As a player, Adam was actually had his body tracked 10 times per second each game. And this AI artwork rethinks this data set that connects goods to his country. So the biometric data collecting was collected not just of Goodies, but all other players via a small device on their back connected to the network. And I suppose for Indigenous people, this carries an extra meaning, and it has a dark past. So this allowed, this artwork allowed the rethinking of this data. So the Tracker Data project is now on exhibition in Adelaide, and invites public to a space to look inside this virtual trunk of the Wira, and it's possible to listen to the sounds of the algorithm blending the recording of the winds with the game data and his voice speaking in his ancestral language. So it's a fantastic turnaround for some of these data collection, and then to be able to turn that into a different thinking around using data in this with Aboriginal knowledge. I wanted to just reconnect and share with you you can actually access some of the Australian AI partners we are working with by looking at the National AI Centre AI Industry Ecosystem Directory, and you can go there by visiting csiro.au/National AI Centre. And finally, I'd also like to invite you to be involved in AI Month. If you have AI solutions or you're working in sport, get involved. We've got AI Month coming up November the 15th to December the 15th. Great time to think about AI, and we're hoping it's going to be a bit of an AI festival. So that's all I have to share around what the National AI Centre is doing. You can follow us on LinkedIn or check out some of our content and join the conversation as well. Thank you very much, Sarah.
Thanks so much, Rita. Well, coming up now, we have all three of our guests coming back for a panel with Martin. So I'll hand over to Martin to reintroduce to you, obviously, Stuart, Rita and John for our panel session. Lots of questions have come in, but also lots of extra information in our webinar chat window. If you want to take a look yourself, there's a few answers already to questions, or at least some extra information in there going off what has already been discussed between Rita, Stuart and John. So Martin, I'll hand over to you now for our panel discussion.
Yeah, Sarah, thank you very much. And Rita, I wanted to start off with something that you mentioned, law and standards. And maybe this is for John and you. John, when we're thinking about AI, and you talked about transparency and explainability, is that where we now have to look at that certain laws need to be implemented and certain standards need to be established? So Rita and John, where are we on that journey here in Australia?
Do you want me to go first?
You go for it, Rita.
Okay. With regards to standards, we actually have an AI management standard that's going to be launched in November, and that's a global standard. And it's going to really help people to be able to look at the way they're managing their AI in their organisation. And that's going to have quite an impact. So we're already educating people around that space and allowing people to get involved in ways that they can also start reporting on their algorithms and be able to conform to this standard. With regards to laws, we have some fantastic laws in place at the moment in Australia, which can protect also the work that is happening in AI as well. John, did you want to add anything further in that space?
Yeah, so just on the laws and the regulations. So this is a very hot topic right now, Martin. There are governments across the world that are currently trying to navigate their way through what is a very complex space in terms of how can they regulate AI, but in a way that doesn't stifle innovation. Probably the leading contender is something called the EU Act, which is now been passed in the European Parliament. But even before that, I mean, there's been a lot of kind of local laws or state laws, or even federal government level laws in different countries. In fact, if you go to the US, there's already over 300 laws that regulate parts of AI in some way, shape, or form. In Australia, the government brought out those AI ethics principles in 2019. Now, they've been voluntary principles, but there is currently a consultation process going on that the Department of Industry is running. It's very, very live right now. There's been a series of roundtables over the last few weeks, and lots of people putting in submissions for what that should look like. So we'll see what comes out of that. I think it's a bit too early to kind of preempt what the answer is there. But the kind of proposal from the Australian government is similar to the EU Act in that laws should kind of take a risk-based approach to things. So there might be certain types of applications of AI that are very kind of low risk, like recommending movies, or others that are actually very, very high risk and should be regulated more, and possibly even things that should be banned outright, which is the EU approach. But if people can find more information about that consultation on the Department of Industry's website.
Yeah. And Rita, you were saying that sport, from your perspective, comparing some of the industries and sectors in Australia, is an early adopter. And where do you come up with that assessment if you compare sport to other sectors?
Well, I'll give you an example. One of my first ever machine learning meetups, which was almost 6 years ago, the main speaker was a guy who had been developing the ability to predict who was going to win soccer. So there's always someone innovating in that space before any other industry. So that's where I see that. And, even coming from Microsoft, there was a lot of focus around tennis globally, golf, cricket, and it's just an area that's very passionate for people, and like looking at ways to use AI in that space is a very innovative aspect.
Yeah, and that's actually an interesting segue over to Stuart. Obviously, with Rita's background, Stuart, if you put yourself into someone who wants to get started, in your experience, or from your point of view, do we just take those things that are available on the internet, like the Teachable Machine or other tools, and just start experimenting? Or have you experienced a different way to approach this?
Well, I think those tools are fantastic. They're no-code environments, essentially, and it means that you can explore the domain, you can retrain models with your own data, and you can deploy systems without having to build all of the kind of the plumbing and infrastructure around it, which is fantastic. I think at the bleeding edge of high-performance sport, I think there are some upper bounds in terms of the usability of those kinds of systems, and certainly I think I'd like to think the place where we play is more in the bespoke and more customized domain. we certainly had to train a lot of our own models, because sport's a distribution all of itself, really. High performance sport, people are performing tasks. They're upside down, they're doing somersaults, they're doing a whole range of out of domain actions that the kind of more public domain models, the broader models are generally not equipped to predict from. So I think as a starting point, yeah, absolutely. But I think it's the bleeding edge is probably beyond the capability of those systems.
Okay, and that's then where let's say you talked about your project pipelines, where effectively you see this as a maybe even a new business model, that AI as a service run in the cloud, and I can subscribe, or I can code without typing lines and lines and lines of code. Is that sort of like
absolutely
emerging on the horizon?
Yeah, well, and it's we didn't build pipelines with commercial outcomes in mind. It's only now that we're starting to consider what those possibilities might be. Our objective initially, in fact, with pipelines was simply to accelerate our own work internally, so that we could build up new systems and deploy them without having to build infrastructure for every different system. But it quickly became apparent to us that there was an appetite and a need across the high performance system for people to be able to deploy our more generalizable AI models, and also an emerging skill set in the sports sector. People are being employed at much greater numbers now in the data science space, and so one of our target audiences for pipelines has been people who are working in data analytics in sport, and who may not be a computer vision expert or an AI person, but have some interest in deriving insight or understanding from imagery. And we can provide the backbone for them to do that, as you describe it, as AI as a service, and allow them to add value. And I think we thoroughly expect that those people, with all of their creativity and their ideas, will add a lot more value to our pipelines as a backbone than we could ever hope to deliver independently.
So John Stewart mentioned that obviously some of the image recognition or pose recognition they can now do on multiple swimmers all at the same time. Where's actually the connection between big data and AI, and is that maybe also what's fueling what you call the summer of AI at the moment?
Yes. So historically there's been two forms of AI, what we call symbolic AI, and then connectionist AI or data-driven AI. So the best way I always have to describe this is if you wanted to create an AI system that would predict what coffee you would order at any given point in time. I'm in Melbourne, so we love coffee here. So suppose that you first thing in the morning, you always take a long black. If it's weekend at friends, you take a cappuccino. And then if it's the evening, you have decaf, let's say. Then you could design that AI system in basically two ways. The first way is symbolic or rules-based. So you would write down a set of rules that would say, if it's before 7 a.m., then it's a long black. If it's at the weekend and John is with his friends, then it's a cappuccino, and so forth. And then when you get enough of these rules at any given point in time, the AI system could search through those rules and could predict the coffee you're going to order based on those rules. That's the traditional AI. That was very popular in the early days. But now we're more, the systems largely rely on this data-driven approach to AI, which requires very, very large data sets. So if you were in the coffee example, if you wanted to create a data-driven AI system to predict your coffee choices, think of it as having a little AI robot on my shoulder that would follow me around for a period of weeks. And every time I ordered a coffee, it would make a little mental note. And then after enough time, it would have collected enough data that it would be able to recognize patterns, and then it would be able to say, actually, you're going to order this particular coffee right now. So those are the two ways to think about it. It's definitely true that right now this data-driven approach is the thing that's driving a lot of the AI development. But there's a lot of interest, and I think we'll see a lot more stuff coming out in the next 5 years on combining these two approaches, because just looking at big data has limitations. If you're just looking at data, you don't have any understanding. But if you actually can combine that with symbols and rules, you can get the best of both worlds. And in fact, some of the work that we do and that Stuart was talking about is kind of an example of this, because we do work on kind of hybrid modeling in AI, for example, that yes, it uses data, but it also might have the laws of biomechanics built in. So you can point cameras at athletes and collect data about how they're moving, but you've also got the knowledge of the physics as well. So you can actually superimpose stress on joints and the physical characteristics of the body as well.
So I have a question which was asked during Stuart's presentation. So Stuart, I might direct this one at you, but please, Rita or John, if you want to jump in afterwards to add to it, please feel free to. How small of a movement can be recorded? A lot of sports that have been mentioned are very dynamic sports and have a lot of movement to track. Has there been any research or implementation for those Olympic sports or other sports around the world where the athletes don't move very much?
Yeah, it's a good question. And it's not necessarily just about whether the athlete moves a lot or not. It can be the granularity of movement that we're interested in. Typically, the state-of-the-art computer vision algorithms at the moment are still relatively coarse in terms of the movement that we can measure, either tracking somebody as they run around a basketball court, which is typically a relatively crude measure, or even estimating pose, although we can do, I think, a reasonably accurate job when we have multiple cameras. But I think what's relevant in sport is not just, although there are certainly some interesting properties to be understood and learned from about the coarse movement behaviours and kind of the interactive movements between players in a team, for instance. But there's a lot of really granular and subtle nuance in the way people move that we miss entirely. So we have to be mindful in all of the work we do in computer vision, AI, sports analytics, about what we are actually missing in the interaction between athletes or in the features of an athlete's performance. Because there is unequivocally a lot of nuance that we don't have the resolution in our systems to measure.
Thank you so much. I hope that answers the question from you, Taylor. Now, we've got a little bit of information that's been added to the webinar chat, and I hope everyone's having a good read in there. So this question is from John. Can the AI help with the mind games of sports as well? Optimizing physical performance technique is one thing, but mental resilience is also a big part of being at the top of a sport. Now, there has been some extra information that's been put into the chat, and one of the websites to look at for mental resilience side of things is called topscience.com with 2 Ps. But feel free to add any extra information in there from all of you if you'd like.
Yeah, maybe I can just add to that, because it was my question. It was prompted by Stuart talking about this system. How can I beat Djokovic? And I was and talking about Nick Kyrgios, and I was particularly thinking of Nick Kyrgios and tantrums that he tends to have, and how you handle that as a player on the other side of the tennis court. And that reminded me that, certainly my own experience weightlifting, a lot of it is mental resilience. If I always say to people, if I'm going to go into the gym and put 155 kilograms on my back, squat down to the ground, and then try and get back up, I better be bloody well mentally focused to do that. So yeah, I'm curious, can the AI help with that mental game as well?
That's a really tricky question. I like to think that we add something. It's a battleground it's a technology battleground in some ways in sport. And I love the idea that our athletes feel as though they're equipped with the best and most state-of-the-art technology possible. The sense of insight, I think, that is derived, that we talked a lot about the interaction between coaches and athletes. So the sense that the confidence, I think, that the athlete derives from knowing that they're getting the best sports analytics and the best technology, and that nobody else has it in the world. I think that's something that we like to propagate, and I think it's one of those intangible features of our game. I think kneeling into the Nick Kyrgios Djokovic example, I think that's maybe a more tenuous association, but yeah, I'd love to explore it.
It's interesting that you mention it, John, because I know that's one of the big fears that people have is around social persuasion and the ability for AI to persuade us. But I love the way you look at this from a more positive perspective. It's like this coaching that could potentially be able to give you strength to be able to take on these things that are just, mammothly difficult. So it's a really interesting point you make.
Yeah, and look, we did some work a couple of years ago where we looked at the ability of AI systems to manipulate people in a positive way. We were looking at, but you can also obviously think that it could be negative as well. It wasn't in the sport context, completely different context, but we did show that if you had an appropriately designed AI system, it could help people make better decisions by presenting things in a certain way and kind of nudging them in a certain direction. So yeah, it'd be fascinating to see if there's value of that in a sports context. And I'm sure people are looking at kind of AI coaches for the masses and things like that,
I've got a question here from Lucy, which is probably more of an ethics type question. Sports data from public realms can be monetized by a lot of different groups, from sports betting to coach couching to creating entertainment content. Are the ethics looking at who owns the data and where those uses of that data is going to be allowable, and whether there's any laws or legislation that is in place or can be put in place in the future that you think we need from this side of things?
I know from understanding the football data that was collected, that is collected by the AFL of the players, and it's not actually shared publicly. So it's interesting to imagine that I think in more community sports, there might be some public data sharing. What do you think, John?
Well, I was going to ask Stuart, because Stuart's the sport expert here. So
come on, Stuart, bring it on. Show us up.
No, I don't think I can. I think sports really late to move on some of these questions. We collect data. Yeah, gosh, I feel like I'm really on unstable ground making any comment at all about these kinds of issues, because it's almost as though we've been working in this space for such a long time, and now suddenly we're going, okay, look, there are considerable issues here to think about. The privacy around the data that we use to train models. We've built substantial models on publicly available vision, but vision of athletes performing, and they're not aware, they've not consented to being involved in training models. And for us, in general terms, we're not working in this space, but it doesn't take much of a thought experiment to start thinking about ways that athletes might be selected, maybe even at a young age, on the basis of AI algorithms. And one of the real challenges with deep learning models is the lack of interpretability and an inability for somebody deploying the model to say, this is the reason that the model has made this recommendation or this prediction. I can't explain it. I can't speak to the reasoning. It's simply a decision that's been made, and I think that lack of transparency is potentially an issue for a whole range of conceivable use cases in sport.
Stuart, maybe to add to that, I think it was late 2021 or early 2022 that actually players in the UK threatened sort of like the data firms about, on the back of GDPR, to say, well, what are you doing with the data, and who owns the data? So I think you're right. In sport, has been an early adopter, as Rita pointed out, but then maybe also needs to now catch up on these questions.
I think sport's often an early adopter in technology, but I think in this particular instance, it's slow to move on a principled approach to the ethics around AI. And I think, you mentioned the kind of the player tracking kind of domain. That's something that's been a consideration for athletes for a long time, because data is being collected about them, and there's not always confidence in the maturity of the ideas that stem from analysis of those data. So could a player, for instance, be unfairly maligned or monitored in a way that's not relevant to their skill set? And I think the way that the data is utilized is important. And I feel like I'm on really unstable ground here. So
and that's, sorry, Rita, go.
Yeah. So what I've actually put in the chat is a great paper around implementing Australia's AI ethics principles. And it kind of gives you a bit of an idea of where we're heading, how to curate your data sets, how to collect the data ethically, a lot of those kind of things. So that's a great starting point. But I do know with sports, it's complex, because, you might have player data, but you might also have video data from watching the game. And that's publicly available. That's on telly. So, there's a lot of fine line discussions around that need to come through. So yeah, the prediction of results is something that I think people will want to do with AI. But anyway, go on, Martin. Sorry.
Yeah. No, and Stuart, just maybe another point, and this is probably now a couple of years old, but in the NFL in North America, there's actually a division, or sort of like within even a club, a Chinese wall between the performance analysts and the back office, because they didn't want to share the data, possibly going into contract negotiations and things like that. But then the question comes, well, maybe the data is just confirming what we otherwise already know. That could be one interpretation. And then my final thought is, think about Kevin De Bruyne, the Belgian football player, who used data to actually show his value compared to other players in contract negotiations not too long ago. So I think it can go both ways. But sorry, Sarah, over to you, I think, for wrapping. Final question.
Thank you. Yes, we have one final question. Lots of great questions in there today. Sorry, we won't get to all of them, but I do want to make sure that everyone gets out of here close to 3 p.m. as we planned. But a last question from Andreas. What's the level of investment in money needed? Now, this is quite an open-ended question, and I'm happy for everyone to kind of jump in with how it might relate to your particular topic that you're spending your time with at the moment when it comes to AI.
I'll go first.
Feel free to jump in.
Absolutely. It's a real opportunity for us, I think, as we look at the 2032 Olympics as being, as said earlier, as being our North Star. We are actively looking for collaboration and opportunities to work. As I said, we've already begun a recent project with Data 61, and I think there are some potential opportunities for substantive and long-term partnerships. There is a lot of enthusiasm across the high performance network for working in this space. What we're not very good at is generating resources and funding to support that work. So, and part of the challenge, I think, in this environment when everybody's got a lot of enthusiasm and where people can in fact, you may not be on this webinar at all if you didn't see the connection between these emerging and nascent technologies and the opportunities in the near and further future. People outside that domain can be a little bit harder to convince. And so I think our challenge as it relates to investment is how do we find ways of taking potential resources from a fixed pie of resources across the high performance network and making sure that we're investing in this space as aggressively as we can.
Yeah, and I would agree with Stuart. I think we do need to find ways to grow the pie. I think the Olympics is a great opportunity if we can get our politics right. You know, we're very good at winning gold medals in the pool. Let's win a gold medal in sports tech for Australia.
He's always very ambitious. But yeah, there is a lot to be done in that space. So I think everyone should get their entrepreneurial hats on and think about what's possible.
Well, thank you so much for everyone for joining us today. We do really appreciate it. And thank you for those questions coming through. Well, hopefully you got your answers that you were looking for. If not, please reach out to the group to Martin at ASTN and we can try and pass those questions on to our guest speakers today and see if we can get those extra questions answered. But once again, a massive thank you for joining us for the ASTN Masterclass, the Artificial Intelligence in Sport Masterclass. Finishing up today, just to remind you that this webinar recording will be available at Digital Innovation Festival 2023. So if you need to look back on this, you can in the future. And also, if you're not already subscribed to the ASTN newsletter and sign up for an ASTN membership, and you can do that at astn.com.au. So thank you once again. It was really great to join you all today. Big thank you to Rita, John and Stuart, as well as Martin. We'll see you for the next one.
Thank you.